Good morning. Today we are going to begin with the very first chapter of class 9th physics, motion. In this chapter we are going to talk about motion and the interesting terms related with motion like displacement, distance, velocity. We are also going to then use these standard terms to derive some equations, and after deriving some equations we are going to discuss their graphs. Furthermore, we will discuss your circular motion. So all of these things are going to be discussed in this chapter. So this chapter is very important as it gives us knowledge why things move, can you describe a motion. So let's move on ahead with this chapter. So if we are trying to learn about motion, the very first thing that we need to know or we need to understand is that what is motion. I've written here what is motion. If you're going to study up about motion, the so you need to know what is motion. This is the question which is asked in the very beginning, that is, what is motion. So let's try to understand this by using an example. Okay, now if you are if you are standing in your room and you are standing near your bed, and it's been a while, it's been 2 minutes or 3 minutes till you are standing, right? You're not changing your position, you've been standing near your bed and just holding your phone, you are just there, you're not changing your position. So if I think that this is my bed and I'm standing right here, right, I'm standing here for about 2 minutes, I'm not changing my position, and maybe I'm using my phone or doing whatever I want to do. Okay, so right now I'm not changing my position. This state in which you're not changing your position, you're remaining where you are, that is termed as rest. Right, now let's suppose that your phone ran out of battery and now you need to charge your phone, right? So what you will do, that you will move from this place to maybe like here where your charger is placed, right? You'll go and then you'll come about here to this position where your charger is placed. So now you go and right here you stop. See, so movement this movement that you have done is basically what it is, motion. So motion is nothing but change in your position. Okay, so when can I say that you have done some motion? Only then when you have changed some position. Okay, for example, you went to your roof and you're standing there looking at the surrounding trees and many other things. Like, can I say that right there when you're standing and just observing you are in motion? No, no, obviously I cannot say that you are in motion at that time. When you change your position, yeah, you move, you make some movement, only then can I say that you have done or performed some kind of motion. So if you try to understand or look at the meaning of motion in some dictionary or try to google it, you will observe that you will get the meaning that motion means movement. So whenever we do some kind of movement or whenever we we change our position, we say that some kind of motion has been done. So that position where you that point where you haven't changed your position is known as rest. So I can define it very systematically as well. I can say that an object is said to be at rest if it does not change its position with respect to its surroundings. So when can I say that an object is at rest? When it doesn't change its position with respect to surrounding. Like right here, it wasn't changing its position with respect to whatever was around it, right? So I said that at that point of time I am at rest. So after some time I made some kind of movement since I needed the charger. So at that time I changed my position with respect to my surrounding. For example, right here I was near my bed, but now I am quite far away from my bed. So I have changed my position with respect to my surroundings. So right here I am at motion. Okay, now you've got to know that what motion is. Now you know that what motion is, what is rest, what is motion. Like, think in this example, I've described my state of rest or my state of motion with respect to this bed, right? To some object. You know what this bed is going to be called as? This at this example, in this example, this bed is not just an object, not just a bed. This is basically my frame of reference. What is this? This is my frame of reference. What is a frame of reference? What does it mean? Basically, a frame of reference is an object according to which, or with respect to which, you describe the position of another object. Okay, it's simply an object, but with respect to this object's position of some other object is described. For example, this bed was my frame of reference, or in this example, this bed is my frame of reference. How can I say that this is my frame of reference? Because at some point of time I was near this bed, so at that time, with respect to this bed, I am at rest, right? I haven't changed my position, but after some time I needed my charger, so I started moving. When I started moving, I changed my position, and then this bed got far away from me. So now if I consider from if a person is sitting on this bed, from his point of view, now I am in motion because I changed my position. So this bed can be considered as my frame of reference, because it is only through the point of view of this bed that I can say that my position has been changed. So whenever we need to describe motion, or whenever we need to see that whether some kind of motion has occurred or not, we need to have a frame of reference with respect to which we try to see if some movement has occurred or not. We will try to understand this frame of reference term later on as well with some more examples. Let's first of all, let's discuss what are the different types of motion, what are the different types of movement that a person can do. So there are basically three types of motion. The first one I've written is translatory motion, then rotatory motion, and then the third one is the vibratory motion, right? So these are the three types of motion that are possible. Okay, now what happens in translatory motion, or what happens in rotatory motion? Let's try to talk about that. In translatory motion, what happens is that this is a type of motion in which there is some change in position of one object in space. Okay, what happens is this: in this type of motion, the particle that you are talking about, or that we are discussing, will change or will move from one point to another in space. Like maybe at one point he will be here, at another point it will go here. So what has happened is it has changed his position from this to this, right? Whenever some kind of there occurs some kind of change in position from one point to another in space, we say that it is a translatory type of motion. Now we can change our position in a number of ways, right? That is the reason why translatory motion can be described in two ways: rectilinear and curvilinear. Okay, rectilinear will be the motion when you are changing your position from one point to another in a straight line. Like this is the road, I was standing at this point of the road, but later on I moved right here, so I've changed my position but along a straight line. So whenever we change our position along a straight line, we call it as rectilinear motion. But sometimes there are curves on the road, right? So if I'm standing at this point and I then arrived at this point, I have performed motion, I have changed my position, right? But I've changed my position along a curved path. If you are changing your position along a curved path, then you can call that kind of motion as curvilinear motion. So this is an example of rectilinear motion, and this is an example of curvilinear motion. So now moving ahead, let's try to talk about rotatory motion. This is simply a motion in which your object moves about in concentric circles. Like for example, we have considered top. It's something of this sort, right? It will, whenever you try to move it like this, it keeps on rotating and rotating. So where it is rotating, it is rotating in concentric circles. So this kind of motion in which your particle of the body moves about or describes about concentric circles about their axis of rotation, this kind of motion is known as rotatory motion. So what is rotatory motion? In this motion, the particles of the body describe concentric circles about their axis of rotation, that is they are rotating about their own axis, right? They keep on rotating. So any kind of rotatory motion, any kind of rotation will be described as rotatory motion. Let's talk about vibratory motion. You might have seen a simple pendulum. A simple pendulum consists of a thin straight with a bob at one end of, and when we try to move it, we vibrate it or move it, what happens is that it attains a to and fro motion, right? It will go here, then it will go here, so it keeps on attaining to and fro motion. So that those kind of objects which attain to and fro motion basically describe vibratory motion. So a simple pendulum is an example of a vibratory motion. Another example is a wall clock which contains a pendulum.